Hello and welcome, my lovely dear students, to another session of my math distance learning class. So today again we are back with a grade 11 and 12 video. This is again in a very important topic, implicit differentiation. So if you have a look at my previous videos, I have made part 1 of the same topic, implicit differentiation, and today I'm back with part 2 of the same lesson, same topic, implicit differentiation, where we are going to see some important exam question. So let's get started. So our learning objective for today would be to solve some very important AP Calculus AB exam questions on the topic of implicit differentiation. So this is a must-watch video for all my grade 11 and 12 students, especially those who are going to be appearing for AP Calculus AB exam this year in 2021. So let's get started. And before we dive into important questions one by one, let's recall from our previous video the steps or the guidelines to be followed while solving an implicit differentiation question. So step 1 would be to differentiate both sides of the equation with respect to variable x. Step 2 would be to collect then the terms which involve dy by dx on any one side of the equation, and then moving all other terms which are left without the dy by dx to the other side of the equation. In step 3, we will factor the terms which have dy by dx on one side, and then finally we would solve the given equation for the derivative dy by dx. So let's apply these 4 steps in solving questions. We begin with questions now. Okay, so let's do the first question, which is an important question from AP Calculus AB on implicit differentiation. So here you need to find dy by dx, and you are given the equation sin x square plus cos y square equal to 1. So in step 1, we differentiate both sides of the equation with respect to x. So that would give you the derivative of sine is cos, so cos x square, and then you have inside x square also, it's a composite function, so we'll go for chain rule, and what we get is 2x. Let's come to the next term. This is cos function and its derivative is negative, so that is sine y square, and then you do the derivative of the inside function, so you go for chain rule 2y dy by dx. The right side will be 0 as you have a constant function there. So that was your step 1. Next we have to isolate the terms which involve dy by dx, so we will keep negative sine y square 2y dy by dx on this side and take the other term on the other side. So that would also give us negative cos x square times 2x. Now both sides you have negative, so you can cancel that out and both sides become positive. So let's now isolate dy by dx. So inside you have 2y sine y square, and here you have 2x cos x square. The last and final step of the question would be where you divide both sides with this factor 2y sine y square, so that you get dy by dx. That gives you 2x cos x square divided by 2y sine y square. And definitely we can cancel out the common factor, which is 2 here, to reach to x by y cos x square divided by sine y square. So that gives us the final solution. Let's put it down here in this red box. So dy by dx is equal to x over y cos x square over sine y square. So this is the final answer. And now I want you to match the correct option with this final answer. Let's now do another important AP Calculus AB question on implicit differentiation. So here the given equation is x square plus 3y square equal to 9, and we are going to be differentiating in step 1 this equation with respect to x. So let's do that. Differentiate with respect to x. So you're going to get 2x here and 3 times 2 times y with dy by dx. Here you have a constant 9 and the derivative of a constant is 0, so you don't have anything left on the right side. Step 2 is to take dy by dx term on one side. So you are going to be keeping this term which involves the derivative on one side and take your negative 2x on the other side. So that gives you 6y dy by dx is negative 2x. Let's do step 3, which is going to be the final step for this question, where we are isolating our dy by dx. So we keep it here and we take the 6y on the other side. So it gets divided, and now you can simplify, cancel out your common terms. So this will give you negative x over 3y. So our final answer for this question is dy by dx equal to negative x over 3y. So I'm sure you are able to understand that the correct answer here is this one. So let's do another example now on implicit differentiation. So here you need to find dy by dx and you are given the implicit function. So I will just highlight here the equation for you, and let's now follow the steps that we have learned one by one to differentiate. So step 1, we differentiate both sides of given equation with respect to x. That gives us dy by dx plus 2 times x plus, now this term has product, e to the power x multiplied with y square. So definitely we'll go for product rule. Let's keep the first function as it is and differentiate the second function. So 2y dy by dx, and now you keep y square as it is and differentiate e to the power x. So that is the same function. And on the other side you have 2 times 2y dy by dx. So that completes step 1. Let's do now step 2. So in step 2 you have to collect all the terms that have dy by dx on one side. So I'm just highlighting here the terms which have dy by dx, and let's simplify them. Open up the brackets and collect everything on one side. So if I'm taking dy by dx here, I have 1 plus 2y e to the power x, and from the other side I have negative 4y dy by dx. Everything else we're taking on the other side. So if I just remove the dy by dx terms, I'm left with 2x and this term. So we are taking both of the terms on the other side, so the sign changes. It's negative 2x and negative y square e to the power x. Again, now we are going to factor out dy by dx. That's step 3. So we are left with dy by dx 1 plus 2y e to the power x minus 4y here. On the other side we have both signs negative, 2x minus y square e to the power x. Let's do the last and final step where we isolate dy by dx. So we are going to divide both sides of the equation with this bracket term, that is 1 plus 2y e to the power x minus 4y. So that gives us the final solution as negative 2x minus y square e to the power x divided by 1 plus 2y e to the power x minus 4y. So now I want you to match the options. So this is the final answer that we have received, that we have got while we solved. So what do you think? A, B, C and D. Which is your correct answer? So I'm sure that you agree with me when I say that the correct answer here for this question is definitely C, because it has the same signs, negative 2x, negative y square e to the power x divided by 1 plus 2y e to the power x and negative 4y. Now if you notice all the other three options which are the wrong options, or I would say distractors here, then you have to be very careful. There's just a minor difference of a few sign and I don't want you to make any sort of mistake. So look at the options carefully, solve the steps and reach to the correct solution. Okay, so let's now solve this guided practice question. So here we need to find the value of the derivative dy by dx for this given equation. So I'm sure you are able to see by looking at this given equation that it is an implicit function. Hence we are going to be doing implicit differentiation. So let's do step 1, which is to differentiate both sides of the equation with respect to x. So that's my step 1. So differentiate both sides with respect to x, and when we do that, on the left side we get 3 times y square dy by dx. So I've applied here a power rule because I have a power 3 here along with the chain rule. Next we have 4y square, so 4 will be as it is being a constant, 2 will come down, power reduces by 1 and again you have dy by dx. On the right side both the terms have the variable x, so it is going to be pretty easy. We just go for the power rule and then add them both to get to this step. So this was step 1 of the question. Now comes step 2. And I'm sure you will be able to do this with me. If you want to check your progress, you can pause the video. So now we are going to collect the terms that have dy by dx. They're already on the left hand side. Everything else is on the right hand side. So let's just factor out dy by dx. So in the bracket, we are left with 3y square minus 8y. That is going to be equal to 5x to the power 4 plus 12x to the power 3. The last and final step here would be step 3, where we need to isolate dy by dx. So we are going to now divide both sides of the equation by this common factor 3y square minus 8y. So that would give us the final answer for dy by dx, that is 5x to the power 4 plus 12x to the power 3 divided by 3y square minus 8y. So that is your answer. Let me put it in the red box so that you know the final step. So that's your final answer for the guided practice question 1. Let's do another one in the next slide. Let's do this now important question on AP Calculus AB. And if you read the question carefully, you are given the two functions fx and gx along with a third function hx, which is defined as the composite function of both f and g. And in the question we need to find the derivative of the composite function. So let's first find hx, which is defined as f times gx. So inside the function f, I'm going to substitute the function g as x over x minus 1. So that would give me, by the definition of function fx, x cube. So it is x over x minus 1 whole cube. This is how my function hx is defined. Now we need to find an expression for the derivative of the function hx. So let's differentiate hx with respect to x. So this is a composite function. Definitely we will go for chain rule. So let's do the chain rule. H prime of x is going to be, now this is a function with power, so power rule will be applied, and that would give us x minus 1 whole square times d by dx of x over x minus 1. That is what is your chain rule that we have applied. So let's simplify this now more. So this is going to be 3 times x over x minus 1 whole square, and for the derivative of this quotient we have to go for quotient rule. So that will be x minus 1 whole square times x minus 1 as it is, derivative of the numerator which is 1 minus x as it is, and the derivative of the denominator which is 1. This is the expression that we have received. Now let us try and rearrange this a little bit so that we are able to write the correct expression for h prime of x. This can be simplified as 3 times x over x minus 1 whole square, and if you simplify this part of your function, then this will come out to be x minus 1 minus x times x minus 1 whole square. Now the right side of this equation, if you compare with all the 4 options which you find here, then definitely this option seems to be the correct answer, because here the right hand side of what we have received while differentiating and the right side of this function is exactly same. So that tells us that C is the correct answer for this question. Now coming to the left hand side where you have h prime of x. Now because we have defined hx as f times x minus 1, which is equal to x over x minus 1 whole cube, so we should be able to write this whole expression in terms of gx also. So if you see how the way gx was defined, it was defined as x over x minus 1. So this whole expression is quite equivalent to writing 3 times gx whole square, and this quotient rule which we have applied, the last step is nothing but your g prime of x. So that gives us also the left hand side of the question, so which completes our answer, and definitely C is the correct answer. That completes our question. Okay, so I hope today's session was quite useful for you and you have understood the concept of implicit differentiation and how you can apply it to solve important problems. So this is one question that I want you to try and solve yourself, and this is a part of your homework for today. There are 4 options A, B, C, D. Look at which is the correct option and post your answer in the comment section. I will be happy to check the answer for each one of you. That brings us to this end of the session today. Thank you for joining, my dear viewers and my dear students. Looking forward to meeting you in the next session. That's all from my side. Bye-bye, and don't forget to like, share and subscribe to my channel for more math videos on different topics. Bye-bye.